Having established the mean value theorem, we are now ready to introduce two important theorems of definite integral, namely first fundamental theorem of calculus and the second fundamental theorem of calculus. In particular, the statement of the so-called first fundamental theorem of calculus says that if f of x is an antiderivative of a function capital Fx, which is continuous over an closed interval a comma b, then the definite integral of capital F of x over the interval is given, as you see it here, that integral from a to b capital Fx dx is equal to fb minus f of a. In order to prove the first theorem, let us divide the interval between a and b in n divisions such that a equal to x0, which is less than x1, and so on, then xn minus 1, which is less than x of n, which is equal to b. Now, fb minus fa then can be written as fxn minus f of x0. Now we can subtract and add f of xn minus 1 and similar terms, as you see it here. This leads us to write it as a summation over n equal to 1 to capital N of f of x of n minus f of xn minus 1. At this step, we are going to use the result of mean value theorem, which says that the difference of f xn minus f of xn minus 1 can be written as f prime of cn times xn minus xn minus 1, as you see it here, where Cn is a point that lies between xn and xn minus 1. Now it is given f prime of Cn is equal to capital F of Cn. Now as you can see it here, we can express fb minus fa as summation over n equal to 1 to capital N f of Cn times delta x of n, where delta x of n is equal to xn minus xn minus 1. Now if you look at the sketch here, then you can see that Cn is a point in between xn minus 1 and xn. Now this summation can be interpreted as the approximate area under the curve capital F of x between the interval a comma b. If you consider the product of fcn times delta xn, then from the graph, as you can see, this is the area of a rectangle having the width delta xn and the height fcn. Now you can see that this rectangle overcounts the area in some region and then undercounts the area in some other region. So as you see it here, in the limit capital N goes to infinity and the interval delta xn goes to 0, fp minus fa can be written as an infinite sum, which is also known as the Riemann sum, as you see it here. And this expression is called definite integral over a to b capital F of x dx. And as you have seen, this expression has the interpretation of being the area under the curve capital F of x over the interval a comma b. Using the statement of the first fundamental theorem of calculus, we can easily establish the so-called second fundamental theorem of calculus. The second fundamental theorem of calculus states that if capital F of x is continuous over an interval and g of x equal to a definite integral from a to x ft dt, then g prime of x is equal to capital F of x. In order to prove this theorem, let us recall the first fundamental theorem of calculus tells us that the definite integral from a to b of ft dt can be expressed as fb minus fa, where f is the antiderivative of capital F. Now by using b equal to x, we can write gx to be fx minus fa. Now if we take the derivative of both sides, you get g prime of x equal to f prime of x, which is equal to capital F of x. This proves the second fundamental theorem. Let us now study few important properties of the definite integral. The first property is that if you exchange the limit points a and b for a definite integral, then the definition itself tells us that this is the minus of the original integral. So if you consider a definite integral from a to b fx dx, then this is equal to minus of b to a fx dx, as you see it here. The second important property is that if you have a summation of two definite integrals such that the first definite integrals is over the interval from a to b and the second definite integral is over the interval from b to c, then as you can see it here, we can express the summation of two definite integral as a single definite integral from a to c, as you see it here. Now let us consider few examples of definite integral. Let us consider the example as given here. Find the area under the curve f of x equal to sin x over the interval between 0 and pi. We have seen it earlier that definite integral has the interpretation of being the area under the curve over the given interval. So as you can see from the sketch, the shaded region denote the area under the curve sin of x between the interval 0 and pi. One can show derivative of cos x to be minus of sin x. So therefore, antiderivative of minus of sin x is cosine x. Now using the value of cosine x at x equal to 0 and x equal to pi, we can evaluate the area under the curve sin x to be plus 2. Let us now compute the area under the same function but over a different interval. Let us find out the area under the curve sin x for the interval 0 to 2 pi. As you see it here, we have already computed the area under the curve between 0 and pi. So now as you can see here, the area turns out to be negative over the interval pi to 2 pi and the answer turns out to be 0. Now if you look at the diagram, you see that between 0 to pi, the area under the curve is given to be positive. On the other hand, the area under the curve between pi to 2 pi is negative. So the total area is 0. Maybe I should emphasize this point that if we are asked to paint the area under the curve sin x over the interval 0 to 2 pi, then you actually need some paint to paint this area. In that case, you need to consider only the magnitude of the area. Let us now consider another example. Find the area between two curves y1 of x, which is equal to sin x, and y2 of x, which is equal to cosine x, over the interval 0 to pi by 4. So let us first sketch the area. So area between the curves can be expressed as definite integral from 0 to pi by 4 over modulus of y1 of x minus y2 of x dx. Between the interval 0 to pi by 4, cosine x is greater than sin x. Therefore, we can evaluate this definite integral as you see it here, which gives the area to be square root of 2 minus of 1. I hope you have enjoyed today's session. In case you have any question, comment or suggestion, please feel free to write them below in the comment section. And if you like to follow the physics discussion here, then you are welcome to subscribe to this channel.